so we looked at the first type of math quiz that we've had in Unit 6. So I figured we go ahead and look at the second type of math quiz we had in Unit 6, which is this rate quiz that we've seen before time and time again. And we remember that rate is the same thing as rise over run, which is equal to delta y over delta x. And remember that your delta just means change. So we're looking in the change of y over the change of x. So the first thing that the math quiz wanted you to do was to determine the difference between our population growth models. So if you look at Population Ecology 6.2 Part 2, this is where you're looking at your two different types. So the two that we're talking about are exponential growth and logistic growth. And exponential, you think about your exponents, right? So if we do 1 to the 1, we know that equals 1, right? So let's go ahead and do a little quick graph here, right? So 1 times 1 is 1, or yeah. I guess we need to pick a better number. Let's pick a better number. 2 to the 1 is 2. And this will start boosting us up quickly. So down here we have our exponent. Over here we have our number. So 2, 1. 1 time, or 2 times 1, 2 to the first is 2. I'm going to get there in a minute, guys. Give me a second. 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. 2 to the second, we know is going to be 4. 2 to the third is 2 times 2, which is 4, times another 2. So that jumps up to 8. 2 times 4, 2 to the fourth, we know is 2 times 2, which is 4, times another 2, which is 8, times another 2 is 16. So that was 3. This is 2 to the 4. And we see that it really starts to shoot up there, right? So we went from kind of close together to boom. So if we do 2 to the 5th, that's times another 2. That's going to shoot up even more to the 32, right? So 2 to the 5th, and that's off the top of our graph. So we know that our exponential, it says, is our ideal when we're talking about populations. And so our logistic, I think of the word logistic to me sounds like logical. Logistic. And so what we see here is more of what we've been talking about in class, talking about our K species, our R species, talking about our carrying capacity, right? And so what our graph tends to look like here is kind of kind of exponential, but then it levels out, right? So logistic levels out. And we know that that is our carrying capacity. And this can be affected by things like running out of food, running out of water, fighting over a mate, fighting over space, or disease. Now there are other things that create this carrying capacity that we've talked about, but those are just a couple of reasons why we can't just continue with this exponential growth that goes up and up and up and up and up and up. So that's how we know the difference between the two types of graphs that we're looking at. Now, to calculate our numbers, this is where a lot of us are getting messed up, is when it says what's the change between, let's look at our exponential graph here, right? What is the change between exponents 2 and 5? What I'm seeing a lot of you guys doing is 5 minus 2 equals 3, and then you're trying to plug that in. That's not how it works, right? So let's back up a second. That's our x-axis, that's our y-axis. I know you guys know that, so there's no big deal. What you need to be doing is you need to find where that 2 is, You need to find where that 5 is, right? And that's our x value. So we know that's going to be on the bottom. So we could say 2 minus 5 or 5 minus 2. I don't care. And all I'm doing is plugging